Hello students, today we are going to see about Fourier series. Any given f of x, a function f of x is given as a series as a naught by 2 plus summation n ranges from 1 to infinity a n cos nx plus b n sin nx. When we expand this one, when we substitute n is from 1 to infinity, this is a1 cos x plus a2 cos 2x plus a3 cos 3x plus etc. When we expand this is b1 sin x, b2 sin 2x plus b3 sin 3x plus etc. So this is what we have here. And for x, we have the limit lambda to lambda plus 2 pi. For full range, we have two ranges. One is full range, the other one is half range. Full range means it has the length 2 pi. For half range, it has the length pi. Full range, for example, if we take lambda as 0, the limit is from 0 to 0 plus 2 pi, that is 0 to 2 pi, the first one. When we take lambda as minus pi, the limit is minus pi to minus pi plus 2 pi, that is plus pi. So minus pi to plus pi. For both these two intervals, the length what we have is 2 pi. So this is for full range. When half range it comes no half of this length, that is pi, we have only one interval 0 to pi. Here we have two intervals 0 to 2 pi or minus pi to plus pi. Here we have only one 0 to pi. In this video we are going to see about full range. And these are the formula for finding a naught, a n, b n. These three are called Fourier constants. A naught, a1, a2, etc. we have no. In general this is a n and in general this is b n. These terms are called as Fourier constants. Here x alone is the variable. For a naught, we have the formula 1 by pi. Here, if the limit is from minus pi to plus pi means the integral minus pi to plus pi we have. In the problem, if they have given 0 to 2 pi as the limit means, we have to take the formula 1 by pi integral 0 to 2 pi f of x dx for a naught. It depends upon the interval what they have given. Accordingly, you have to change the limits of the integration. A(n) is equal to 1 by pi integral minus pi to plus pi. The same thing. If the limit is from minus pi to plus pi means we have to take these two. If it is 0 to 2 pi means we have to change the limits as 0 to 2 pi. F of x cos nx dx and bn is 1 by pi integral minus pi to plus pi f of x sin nx dx. Now come to the problem. We are going to express f of x, the given f of x 1 by 2 into pi minus x as a Fourier series of the period 2 pi and the limit what they have given, interval what they have given is 0 to 2 pi. After getting this, after expanding this as a Fourier series, we also have to prove 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus etc. is equal to pi by 4. So first we have to expand this using this formula, and after that we have to substitute value for x and we have to get this series. Okay, already we know that f of x takes the formula a naught by 2 plus summation n ranges from 1 to infinity a n cos nx plus b n sin nx, where a naught is 1 by pi integral 0 to 2 pi because the period of integral is 2 pi and the interval what they have given is 0 to 2 pi. So the limits are from 0 to 2 pi. F of x dx, this is for a naught. And an is 1 by pi integral 0 to 2 pi an cos nx and bn is 1 by pi an sin nx dx. Now come to the calculation of a naught. Sorry, it is a naught. A naught is equal to 1 by pi integral 0 to 2 pi f of x dx. The given f of x is 1 by 2 pi minus x. So which is equal to 1 by pi. 1 by 2 is constant, so I can take the 2 outside. Now pi minus x we are going to integrate. Pi is constant, so pi into dx. Pi into dx, integration of dx is x minus integral x dx. When we integrate x, what we are getting? X squared by 2. And the limit is from 0 to 2 pi. I'll tell you the general integration formula for x power n. Integral of x power n dx is equal to x power n plus 1 by n plus 1. Integration of a constant into dx is equal to constant, we can take integral dx, which is equal to c into x. So this we applied for the first one. In the place of c we have pi, and the second one we used this formula. In the place of n we have 1. So 1 plus 1, that is 2 by 1 plus 1, that is 2. Now we are going to apply the limit 2 pi and 0. Constant what we have outside is 1 by 2 pi into the upper limit what we have to apply is 2 pi. So pi into 2 pi minus pi squared by x squared by 2, that is 2 pi the whole square by 2. So this is for upper limit minus, since the lower limit is 0, totally that value is 0. So which is equal to 1 by 2 pi, and this is 2 into pi squared minus 4 into pi squared by 2. When we take 2 as the LCM, 1 by 2 pi into 2, when it comes there, 4 pi squared minus 4 pi squared. So these two will get cancelled, that is 0. So the answer for the constant a0 is 0. Now come to the calculation of an. The constant an is equal to 1 by pi integral 0 to 2 pi f of x cos nx dx, which is equal to 1 by pi integral 0 to 2 pi f of x given is 1 by 2 pi minus x cos nx dx. This 1 by 2 is constant, so we can combine that with pi. So 1 by 2 pi integral 0 to 2 pi minus x into cos nx dx. How to integrate this integral? You heard about integration by parts, no? What is the formula we have? Integral u dv is equal to uv minus integral v du. Am I right? We can use this here, but I will teach you the general formula. This formula is we got from the general formula. So I'll teach you the general one. Since here the x power is 1, this integration by parts we can use. But when we get the higher powers, x squared or x cubed like that we have here, means we are not able to apply this integration by parts in a single step. We have to take that, it will take more steps. So better we can learn the general formula, which is called as Bernoulli's formula for integration. The formula is integral uv dx is equal to uv1 minus u dash v2 plus u double dash v3 minus etc. Alternative plus minus will come. V whatever we are fixing, no, that we have to integrate subsequently, and u what we are fixing, no, that we have to differentiate next time. Okay, so first you have to decide which is your u and which is your v. Excluding this constant, this integration alone I have taken, and I am going to use Bernoulli's formula for this. After getting the answer, we can multiply that with this 1 by 2 pi. Okay, already I told you in the formula we have uv dx. So excluding this dx, we have to fix which is our u and which is our v. Suppose, for example, if I take this as u, for example, so u is cos nx. What is the next thing we have to take? U dash. When we differentiate this, this is minus sin nx, into n will come, right? When we differentiate, the coefficient will come as a product. And when we differentiate cos, we'll get a negative sign. So u double dash is equal to minus cos nx into, already we have one n squared. Then u triple dash minus into minus plus sin nx into n cube, like that subsequently we will have, right? And when we integrate this one, because when we fix the other one as v, means v is pi minus x, then v1, that is integration of this, integrating this is pi x minus x squared by 2, then v2 is integration of this, so pi x squared by 2 minus x cube by 3 into 2, 6, like that we will have. But What we have as a formula is plus etc. Somewhere we have to end the formula. So the ending term we will decide using this u. So when we differentiate this subsequently at some stage, at some derivative, we have to get the answer as 0. So keep this in mind. Whatever term having u, know that you have to fix as u. Sorry, whatever term having x, know that you have to fix as u, and the other term as v. For example, if we take here u is pi minus x, am I right? Then u dash is 0 minus 1, that is minus 1. Then u double dash is 0. So in this step we got constant. After that, when we differentiate, that term will become 0. So this is the ending of the integration. So keep this in mind. Whichever term having x, that term is u. The other term is v. So v is equal to cos nx. This v we have to integrate. So v1 is equal to, when we integrate cos, it is plus sin nx by the coefficient n. Then v2 is equal to, when we integrate sin, it is minus cos. So minus cos nx by, already one n is there, again one n, so it is n squared. What is the formula we have? u v1. So u into v1. Then u dash into v2. So u dash into v2. Then u double dash into v3. No need to find what is v3 because u double dash is 0. So this is what we have to stop. Only up to this term we have to calculate. Now come to the formula u into v1. That is pi minus x into sin nx by n, and the limit is from 0 to 2 pi. The limits are from 0 to 2 pi. Minus, in the formula we have minus sign, and multiplication of these two, this is minus sign and this is minus sign. Minus into minus plus, but in the formula we have one minus sign. So totally this term will be in minus sign. So minus of cos nx by n squared, because this is 1, no, when we multiply it is just cos nx by n squared with the negative sign, and here the limit is from 0 to 2 pi. Now we have to apply the limits 2 pi and 0. We know that cos n pi is minus 1 power n, sin n pi is 0 when n is an integer. For example, when we take this, no, cos, if I take n as 1, cos pi is equal to minus 1 power 1, so it is minus 1. Then I take, when I take n as 3, cos 3 pi, which is minus 1 power 3, which is minus 1. Cos 5 pi, when I take n as 5, cos 5 pi, which is minus 1 power minus 5, it is minus 1. Like that, when we take the coefficient as odd, cos pi, then cos 3 pi, cos 5 pi, all having the value minus 1. When we take even values, cos 2 pi, cos 4 pi, etc., it is plus 1. Okay. What about this one? Cos 2n pi, it is always plus 1, because cos n 2 pi, if I take, no, it is minus 1 power 2 into n. Even this I can rewrite as minus 1 the whole squared, the whole power n. Minus 1 the whole squared is plus 1. Plus 1 power n is always plus 1. So take this as a formula. Cos 2n pi is always plus 1. Sin 2n pi is always 0. If it is n pi, it takes values plus 1 and minus 1. But if it is 2n pi, it is only plus 1. Now come to the limit. We have to substitute 2 pi first. 2 pi. Already we know that sin n pi or sin 2n pi is always 0. Okay. So 2 pi, when I substitute, this will become 0. When I substitute the upper limit, it is 0. Minus, when I take 0 as the lower limit, we know that sin 0 is always 0. So both the limits, when we substitute, no, this value will become 0. The first one will vanish. Come to the second one. The second one having minus sign, minus 1 by the coefficient I am taking separately, n square. Okay. Now apply the upper limit, cos n x. The limit what we have is 2 pi. Already I told you cos n cos 2n pi is always plus 1. So it is plus 1 minus, what is the lower limit we have? 0. What is the value cos 0? Cos 0 is 1. So plus 1 minus 1. This is also 0, 0, 0. So totally this value will become 0. So what is my an? An is equal to 1 by 2 pi into the evaluation of this integral. This integral is 0. So totally we are getting an as 0. Already we got a not 0. Now an is also 0. Now come to the calculation of Bn. Bn is equal to 1 by pi integral 0 to 2 pi f of x into sin nx dx. Here the given f of x is 1 by 2 pi minus x sin nx dx. Here also we are going to apply Bernoulli's formula. Take the constant 2 outside. So 1 by 2 pi 0 to 2 pi pi minus x into sin nx into dx. Already I told you the term, whichever term having x, that is u, the other term as v. So u is equal to pi minus x, u dash is equal to 0 minus 1, which is minus 1, u double dash is equal to 0, and v is equal to sin nx v1, that is integration of sin nx, that is minus cos nx by n, and v2 is equal to minus sin nx by n squared. So multiplying these two, which is equal to 1 by 2 pi. The first one is u into v, plus into minus, so the term is minus pi minus x into cos nx by n. This term is plus and this term is minus, so plus into minus, minus. The limit is from 0 to 2 pi minus integral this into this. Already both are having minus sign, so minus into minus plus the next term minus, not integration, multiplying these two, u dash v2. So minus into minus plus, in the formula we have negative sign, so totally it is in negative sign. 1 into this thing, so just we have sin nx by n squared. The limit is from 0 to 2 pi. Now for this term, when we apply the limit, 2 pi also will give the value 0, 0 also will give the value 0, because we know that sin 2n pi and sin 0 both are having the answer 0. So upper and lower limit, when we apply, the second term will become 0. Now come to the first term, we have to apply the limits. This minus I am taking outside, so minus 1 by 2 pi. The upper limit what we have is 2 pi. So 2 pi I am substituting for x. So pi minus x we have. So it is 2 pi cos n x. That is cos n 2 pi by n. This is my upper limit minus the lower limit. I have to, this minus sign I have taken outside. This lower limit when I apply, it is pi minus 0. 0 I have to substitute as, sorry, x I have to substitute as 0, cos n 0. So that is cos 0. Cos 0 by n. So I have taken upper and lower limits. So minus 1 by 2 pi. Pi minus 2 pi is minus pi. Cos n 2 pi. Cos n 2 pi is plus 1. Already I told you. So 1 by n minus pi. Cos 0 is 1. So minus pi by n. So which is equal to minus 1 by 2 pi minus pi by n minus pi by n. Both are having same denominator. So we can add minus 1 by 2 pi into minus 2 pi by n. Both are having same denominator. So we are adding the numerators. So it is minus 2 pi. 2 pi we can cancel. Minus we can cancel. So it is 1 by n. Therefore Bn we got as 1 by n. Already we got a0 and an both are equal to 0. Now come to the formula. This is the formula what we have, an by 2. And we got a0 and a0 by 2. I am sorry, a0 by 2. a0 is 0 plus summation n ranges from 1 to infinity. N is also 0 plus bn we got as 1 by n sin nx. When I expand this, when I take n as 1, the first one is 1 by 1 sin x plus 2, 1 by 2 sine 2x plus 1 by 3 sine 3x plus etc. This side I am taking the given f of x. So 1 by 2 into pi minus x. Therefore, we have expanded the given f of x 1 by 2 pi minus x as a series like this. In the question, they are asking you to expand the series, and from that series we have to reduce, we have to prove this result. 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 etc. up to pi by 4. How to get that result, this result? What is the range, what is the limit given? 0 to 2 pi. We have to substitute x values within this range and we have to get this series. Okay, so we have options. Either I can take x as 0 or x as pi or x as pi by 2 or x as 2 pi. Within this limit we have to take x values and we have to get the result. For example, if I take the first one, x as 0, sine 0, sine 2 0, sine 3 0, all the values will become 0, so we are not able to get this result. If I take 2 pi, sine 2 pi, sine 4 pi, sine 6 pi, everything will give the value 0. So we are not able to get the required result. So this one we are not able to take and this one also we are not able to take. Come to this pi. If I take sine pi, sine 2 pi, sine 3 pi, again I'll get the value 0. So this one also I am not able to substitute. So you people have to decide which x value we can take depending upon the result what we are going to prove. For proving this result only we can take this x as pi by 2. So on substitution of x as pi by 2 we are getting 1 by 2 pi minus pi by 2 plus 1 by 1 sine pi by 2 plus 1 by 2 sine 2 into pi by 2 plus 1 by 3 sine 3 into pi by 2 plus etc. Taking the LCM, it is 1 by 2, 2 pi minus pi by 2. With this side, it is sine pi by 2 plus 1 by 2 sine pi plus 1 by 3 sine 3 pi by 2, etc. Sine pi is 0, sine 2 pi is 0, then next term is 0. So all the even terms will become 0. Already we know that sine pi by 2 is 1. Sine 3 pi by 2 is minus 1. Sine 5 pi by 2 is plus 1. Alternative plus minus will come. Therefore, this is 1 and this is minus 1 and this is plus 1. Therefore, on substitution of the values 1 by 2, simplifying this, we are getting pi by 2 which is equal to 1 and this term is minus and the next one is plus minus etc. So, plus minus will come. So, this is pi into 2 into 2 4, pi by 4 is equal to 1 minus 1 by 3 plus 1 by 5 minus etc. This is what we had to prove. We have proved it. So if they are asking you to prove any series, you have to decide within this interval whichever value is applicable based on the Fourier series what we got now here. Based on this, you people have to decide, but that value should be within this. Is it clear? Thank you.